Hello students, my name is Wahidullah and I am chemistry lecturer here at Cordoba School and Colleges. Dear students, it's our fifth lecture of first chapter of class 10th, and that is chemical equilibrium. Today's lecture content is to define or to tell you about the conditions which are necessary for equilibrium, while the second content is factors that affect the equilibrium state or equilibrium conditions. Dear student, there are certain conditions which is necessary for equilibrium. The first condition that affect or that is necessary for equilibrium, that is the chemical system should be closed, which means that the chamber in which we are performing reaction, so that chamber or that chemical system should be a closed one. It shouldn't be an open, because in open system there is possibility of escaping the reacting substances. So as a result, that will affect the concentration of reactant and product, which is the second condition for equilibrium. Concentration of reactant and product should be the same. Number third is the temperature of the system will not be changed. Pressure of the system will not be changed, as well as volume of the system should be remains the same. How concentration, temperature, pressure and volume affect the equilibrium state or equilibrium conditions, shortly we are going to discuss that. And remember students, one specific condition that is most necessary for equilibrium, and that is the reaction should be a reversible reaction. Last is catalyst. The catalyst used in the chemical reaction will remain unchanged. Dear students, now how the factors affect the equilibrium state. So there is a principle in chemistry, and that principle is called Le Chatelier principle or Le Chatelier principle. According to that principle, if an equilibrium state or equilibrium condition of a chemical system or a chemical reaction is disturbed by any means, the system will try to achieve equilibrium state by either shifting the reaction in forward direction or in backward direction. We can also define Le Chatelier principle as, if an external stress is applied, stress means a change is applied to a reacting system at equilibrium, the system will adjust itself in such a way that the effect of the stress is nullified. There are many factors that affect the equilibrium state, and among them the first one is effect of concentration. Dear students, how the concentration affect the equilibrium state? So increase in the concentration of reactant at equilibrium will shift the equilibrium towards the right, which means that the reaction will proceed in forward direction in order to reduce the amount of a reactant so that equilibrium state is achieved. Secondly, increase in the concentration of product causes the equilibrium to shift to the left, which means that the reverse reaction will be favored. Dear students, change in the concentration and its effect on equilibrium. So now, when we increase the concentration of product, the equilibrium will be shifted towards the left, which means reverse reaction will be favored, while decrease in the concentration of product result in the shifting of equilibrium towards the right, which means forward reaction will be favored. Similarly, increase in reactant will shift the equilibrium towards the right, while decrease in the reactant will shift the equilibrium towards the left. Dear students, let me give you a general example, and in that general example actually A plus B react and they give the C plus D in a reversible chemical reaction. Here A and B are reactant while C plus D are product. As we discussed in the previous slide, that there could be four possible ways in order to explain the effect of concentration on equilibrium. So consider the reaction is at equilibrium. So what will happen when we increase the amount of the concentration? The equilibrium will be shifted towards the right, which means that the forward reaction will be favored. While the second condition is when we increase the concentration of the product. So then what will happen? The equilibrium will be shifted towards the left, which means that the reverse reaction will be favored. Dear students, taking the same example for other two ways or cases, when we remove the concentration or when we remove some amount of concentration at equilibrium, so the equilibrium will be shifted towards the left in order to increase the concentration of those reactants and to achieve the equilibrium. Similarly, when we remove the amount of product, some amount of product at equilibrium state, so at that time the equilibrium will be achieved when forward reaction is favored, which means that the equilibrium will be shifted towards the right. Dear students, now it's time to explain what is the effect of temperature at equilibrium state. So consider this general reaction in which A plus B react and they gives us C plus heat in a reversible chemical reaction. Dear student, as I discussed earlier, that a reversible chemical reaction is consists of two parts. One is forward reaction while the second one is reverse reaction. So keeping in view about this specific chemical reaction, so in a forward reaction A plus B react and they gives us C plus heat, which means that the forward reaction is exothermic. And if we look at the reverse reaction in which C plus heat combines and they gives us A plus B. Here heat is given to the system, so the reverse reaction here is actually endothermic reaction. Now what will happen when we add heat? So when we add heat, as you people can see that the reverse reaction need heat. So when we add heat, the reverse reaction will be favored and equilibrium will be shifted towards the left. Similarly, when we reduce the heat, so the forward reaction will be favored and the equilibrium will be shifted towards the right. Dear students, now to study the effect of pressure or volume, we know or we have studied in our previous classes about Boyle's law, which can be explained as the volume is inversely proportional to the pressure, which means that when volume is increased, pressure will decrease, or when volume is decreased, pressure will increase. Dear student, this is a general reaction in which A plus B react and they give us C. The subscript G means that both or all the substances are in gaseous form. So in the forward reaction, two gas molecules react and they give us one gas molecule. While in reverse reaction, one gas molecule decomposes and they give us two gases molecules. Dear student, now what will happen when we change the volume or when we change the pressure? So, dear students, when we add gas molecules, so what will happen? Increase in the volume of reactant will occur. As a result, pressure will be decreased. As I told you, that increase in the volume will result in decrease in the pressure. So when we add gas molecules, so volume of the reactant increases. As a result, pressure of the gases or pressure of the system goes down. In order to attain the equilibrium or achieve the equilibrium state, the volume of the gases should be reduced by favoring or by carrying out the forward reaction. When forward reaction is favored, as a result, two gases molecules will be converted into one gas molecule, which result in decrease in the volume. As a result, the pressure will increase and equilibrium will be achieved. Now, what will happen when we remove gas molecules? So when gas molecules are removed, which means that the volume of the system is reduced. As a result, the pressure of the system will be increased. So at that instant, what we have to do, or what the reaction system have to do, we have to increase, or reaction system have to increase the amount or the volume of the gases. So the amount or the volume of the gases will be increased when reverse reaction is favored. So here, when we remove the gas molecules, reverse reaction will be favored. As a result, the volume of the product will decrease. Here, by product, I mean that when reverse reaction is favored, so the product will be A and B. So here, when A and B are formed, so volume will be increased. As a result, the pressure will be decreased and equilibrium state will be achieved. Students, remember that this condition only applies to gases. Okay, that was all about two topics, and these two topics were actually list of the conditions that are necessary for equilibrium and the factors that affect the equilibrium state. Okay, thank you so much. Work hard, students, work hard. Okay.